This is a video for the GCSE Physics course, or it also applies for the GCSE Combined Science course as well. This, of course, was a request from a student, and Nando, you know who you are. Right, first of all, what we have here is a model of an atom. And you can see electrons whizzing around the nucleus of an atom, and inside the nucleus you can see protons and electrons. And that's basically the structure of an atom. This is a very large atom, by the way. You can see, just look at the sheer number of protons and neutrons in there. So it's fairly unstable. It's got lots of energy in it, and the atom will want to get rid of it. The next slide shows us a radioactive material. It's about 5 millimeters across, and it's inside something called a cloud chamber, which is used to display the emissions coming off it. Those little silvery clouds are basically vapor trails caused by alpha particles ionizing the air it goes through. In other words, the alpha particles smash up atoms and rip off the electrons, leaving ions in the air, and then bits of alcohol cloud gather around it, and you can see them quite clearly. The reason that atoms are radioactive is because they're unstable. They've got too much energy. They may have too many protons or neutrons. More often than not, it's more a question of more neutrons than anything else. And the way they lose weight is, or mass or energy, is by throwing out alpha, beta, or gamma rays. You can detect these with a cloud chamber, as you see here, or with a Geiger-Müller tube. If you use a Geiger-Müller tube, you would be able to count the number of decays per second, and the activity of a source is measured in becquerels, and this stands for decays per second. As a matter of interest, a human being has got about 3,000 becquerels. In other words, you give out 3,000 radioactive decays in all directions every second. Now, we need to know a little bit about what we mean by random. None of us can predict as to how many decays this will have. We have a rough idea, but it is generally one of the few random things out there. This cat appearing, you may say, well, that's a bit random. Well, I knew that was going to happen. It wasn't random, but to you it may seem random. Radioactivity is genuinely random. Right, let's have a look as to what alpha particles are. Alpha particles are made of 2 protons and 2 neutrons. They are, in fact, a helium nucleus. They're missing the electrons. You can see here the symbol for alpha. Right, the alpha decay equation. Well, if we look at this here, we've got uranium 23892. 238 is the mass, 92 is the number of protons, so we've got 92 protons. We have 146 neutrons, and if you add those together, you end up with 238, which of course is the number at the top of the uranium symbol, and that goes on to make helium 42. There you go. Plus, of course, the helium has got 2 protons and 2 neutrons, making a total mass of 4, which is the number you see at the top of the 42He. Plus, it makes thorium 23490. This means it's got 90 protons and 144 neutrons. If you add 90 and 144, you get 234 at the top there. In the exam, you're not going to be expected to know what element is created, but you are expected to know that helium, the alpha particle, is basically He42. Now, if we add up the 4 and the 234, you get 238, and that, of course, corresponds with the number you have across there. Smiley face. Good. Right, the next one, a beta decay. Well, it's basically when a neutron changes into a proton and an electron. The electron is thrown out of the nucleus at high speed, and the proton stays behind. The charge of the nucleus increases by +1. Okay, so the equation is here. We've got carbon 14, which of course means it has got 14 things in the nucleus, 6 protons and 8 neutrons, and that goes and forms a beta particle, which is written down as an E because it's an electron. 0 minus 1. Minus 1 shows the charge. The 0 at the top says how heavy it is. Plus 14, 7. If you notice, you'll see that the number 14 at the top equals 0 plus 14, and the number on the bottom in the blue circle, 6, equals -1 plus 7. So it's balanced. Okay. In gamma radiation, the electromagnetic radiation is emitted from the nucleus. Basically, it's the nucleus got too much energy, it's lost something, and it sort of rejigs itself to make itself a little bit smaller, and in doing so, it releases that extra potential energy out in the form of a gamma ray wave. There's no mass number or atomic number change. You can see the formulas there. Okay, you also need to know that neutrons are a type of radioactive decay. Apart from alpha, beta, and gamma, there's a 4th type of radioactive emission. Sometimes just a neutron may be emitted. You need to know about the property of different particles. So Alpha particles will get stopped by paper. Beta particles will go through paper, be stopped by aluminium, and gamma will go through paper, aluminium, go through a lot of lead and concrete. It won't be stopped entirely, but it will be severely weakened by it. So this is summed up as saying that helium will go through about 5 centimeters of air, beta will go through about 1 meter of air, and gamma is limitless. It'll go across, massive amounts of space, including the whole solar system, quite easily. Also, the other thing to know is that alpha is very ionizing. It's a large particle. It's very ionizing. Beta particles are quite ionizing. In other words, ionizing means it'll damage atoms and split them into positive particles and negative particles, which tend to be the electrons. The positive particles tend to be what's left of the atom once the electron's been kicked off. Gamma is weakly ionized, and that is why it travels enormous distances. Alpha particles are used in smoke detectors, so they'll get stopped by smoke, for example, in a fire alarm. Beta radiation is used for thickness detections, for example, aluminium foil. And gamma rays is used things such as in radiotherapy, killing tumours and sterilising equipment. A burst of gamma radiation can kill, destroy DNA and kill life as such. Now, if I was up to you, I would now blurt, in other words, write down everything you need to know about this subject, which include, for example, that radiation is when unstable atoms emit particles to become more stable. That alpha is written down as 42He. It goes through 5 centimeters of air. It's stopped by paper and it's used in smoke detectors. I would expect you to know that beta has got the symbol 0-1e. It can travel up to 1 meter in air and is stopped by aluminium, and it's used in thickness detection. And that gamma is an electromagnetic wave. It travels at the speed of light. It's partially stopped by thick lead or concrete, and it's used in radiotherapy and sterilizing. Also, if you notice, alpha particles are very ionizing, beta is quite ionizing, and gamma is very weak ionizing. That is the end of the video.